into that. It's a little deep, but okay. So from the get-go here, and basically know that there was a bunch of atoms before, and they gravitationally attracted into one infinitely seeming at the time, or what we know it to be, one atom, and then bam, and then gravity was released. Anyways, and the inflationary period, this is like 10 to like a sextillionth of a second. Basically, see, I'd like, so many details on it. I'm trying to keep this thing cut down as much as possible so it ain't fucking like 2 hours long, and it probably already is. But basically, in the inflationary period, it grows from like an atom to the size of a grapefruit, on up to within the first on up to the size of the Earth. And they say that it's traveling faster than the speed of light. The outer ring of space is traveling at faster than the speed of light. That's a whole other reason why it can do that. It's anti-gravity. Yeah, it's actually I have to get in a lot more. But anyways, the second stage here, at 10 to like a quadrillionth or something like that of a second, the post-inflationary period. And at this point is where the quarks and electrons are getting formed, but they're so hot, it's so hot they're moving at rates of speed that they don't stick to each other. The quarks don't stick to each other. And anyways, and yeah, it's very violent, a lot of craziness going on, like to the point electrons are like disappearing and reappearing, and anyways, it's just madness, unstable in its rawest essence. And then you come up here and it cools down a little bit enough. The universe is expanded out enough to where it cools down. You see the cooling right here, and there's some kind of inherent. It's hard to say necessarily exponential in this terms because there's so many different things going on. It needs more research, but it's definitely upon each one's getting smaller upon itself. But exactly how conclusive, to be honest, at this point right now. But okay, it's cooling enough to let quarks form into protons and neutrons. So the nucleus of the atom. And they come here, and then this is the fourth stage, and then it's cooled down, but it's still a super hot fog, and it's not allowing any light through at all. So lightless at this point. But even before this, you got like a picosecond. Up to a picosecond is like the electroweak period, the electromagnetic and weak force combined. They say where it there's a lot more in depth on that too. But and then up to the microsecond is the hadron epoch, where other variants of that quarks, baryons and mesons were formed anyways, like I said. But I'm saying this because there's things going on in here that lead up to this that explain the exponential, I guess expose the exponentiality that this is not doing. I need a better picture, obviously. And then on up to a second is basically right around when the leptons, they say the lepton epoch, and that's when tau and muons, some of the most massive particles at that time, which anyways, they decayed, but that's what actually nowadays we're even using particle accelerators to manifest these things by slamming these things together. Anyway, we're creating things that we did back at the Big Bang. Now, it's pretty incredible. But anyway, so there's things that here you don't see that I was trying to kind of explain, but I'd have to go into much more depth on actually every single stage down the road sometime. But 3 minutes in, that's 3 minutes in, and then on up here, 300,000, and even in between here, 3 to about 20 minutes, they say up to about 20 minutes was the photonic, basically photons, it's the lights. Lights came on and that's huge. But anyways, and that's something that on up to about 300,000 years ago, it cooled off, expanded out enough and cooled off enough to where these electrons, these crazy guys over here, are finally slowing down enough to where they can stick with the quarks that have stuck together into neutrons and protons to form a nucleus. The electrons are sticking to them to where they can finally form atoms. Huge deal. On up to something like we're missing here again, it was 100 million years, give or take, is the formation of our stars. And then about a billion years, you had photogalactic mergers that formed galaxies that turned into galaxies, and then on up to basically our galaxy somewhere in here. I would say I literally haven't found anything conclusive. 6 to 10 billion years our galaxy formed on up to our solar system, and then on up to 4.5 billion years ago, Earth. And then back from then, you're going up there. On down. Now this is what is incredible about this, is this time here. It's getting, these little tiny things are getting bigger upon themselves to where, exponentially bigger. These occurrences, these big occurrences are getting exponentially bigger until they do a turn on up to Earth. Because look at this. It's getting bigger, 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 bigger. The evolutions that leading up to us, bam, 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 and others like I mentioned, and then it turns and starts getting smaller. Bam, 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 smaller. It's leading back to the collapse. Is basically what it's doing. It's real. It's some real shit. It's going to collapse. And basically what it is it's all collapse and explosion. It collapsed to explode the Big Bang, and then there's a bunch of things like technicalities like collapses in here. But I'd say probably the closest one that I could explain at this point without going extremely in depth would be the formation of the first stars, which was hydrogen atoms, not technically collapsing, but they came together to form the stars, the clouds of gas that collapsed to form the star. Anyways, like a lot of this stuff, definitely would have to go more in depth on without stretching this out forever. But infinity and then some, plus 2 to the third power. Minus that statement. I wish I wouldn't have said that. God dang dumbass. I'll probably edit it. Probably not. I'm lazy. But, okay. And then on up to the star that collapsed to form the first black hole that turned into a supermassive black hole that housed the galaxy. And there was, within the galaxy, a star exploded that made the nebula that would become our solar system, made the nebula collapse that would become our solar system, create our sun, and then within that, more gravitational collapse created Earth. And then basically, all of this is collapse. Bam, bam, build up, build up, build up, collapse. Build up, build up, build up, collapse. Build up, collapse. And then actually, the collapse becomes so frequent, it's going to take some time to map them all out, but basically recessions and, oh goodness, everything. There's so many collapses now, they're so frequent, they're everywhere, all the time. The collapses, they happen all around us. But basically that's the idea, is that it's exponentially expanding. We are exponentially evolving to catch up with it, and we're annihilating particles now, they say, to try to find the God particle, the Higgs boson, which happened around the Big Bang that created all this mass. So once we start annihilating these particles and set off some kind of intergalactic, I don't want to go that far, so set off some kind of chain reaction, chain of events that exponentially creates mass to where we fill up the universe with, make it so dense that it collapses upon itself. Because the reason gravity is getting weaker is because the more that the universe expands, it's stretching density out, and the gravity becomes weaker as electromagnetic repulsion that keeps the atoms apart becomes stronger, or apparently appears stronger. Because all these atoms would just suck together. Me and this screen would always be stuck together if it wasn't for electromagnetic repulsion. So basically, once we fill the universe with density, it's going to slow this down. And I'm not even going to get into the aspect of time and what's happening. As this is expanding, the faster it expands, the slower time goes. So anyways, I'm not even going to get into that. It might scare you. But so basically, once we fill it, it's going to overpower electromagnetism and go. And the reason I'm so sure of this is because the Big Bang happened in the first place, and the first fundamental force to break away was gravity. But anyways, another little revision here. Like, I really need to just have this mapped out and have somebody interview me to do this correctly. But they're saying that it's dissipating to where this is what's widely concluded now, is that it's dissipating to the point to where it's going to fade into a thin to a non-existent state. It's going to become so cold that nothing. Time will cease. Everything will cease existence within itself. So actually, we are fueling immortality by making the universe collapse. And I guess you'd think cutting off consciousness, but there's no such thing in the sense of it's all a singularity at always. It just doesn't seem to be. We're going to expose the singularity more and more. We are. It's becoming more and more evident, and as we merge with the machine, but even get closer on down to playing on the subatomic level, and it's much more in depth. I'll go in the paper. To keep it from dissipating, we're going to grab it using gravity and keep these atoms closer together to where they come back, and it plays out all again. But next time, even, what it's going to do, it's going to be that much more. It's going to be, what'd you say?
The Roman
multiplied by the proportional value, not
the
even
Dark Ages.
It's going to be exponentially increased by the proportional value, which is exponentially evolved.
Make sure you heard that.
The mass will be exponentially greater as what's getting formed in this universe, especially after we, not only what's got formed, because that got formed in the last universe. This is what we're about to all create up on, like after we get the Higgs boson and all that and start using that, create it exponentially to keep the universe from collapsing on down, so the next time it explodes it's going to be exponentially greater by the proportional value, which is expanding. It's incredible, basically, plain and simple. If you're this far, you know. I don't really give a damn. But to be honest, I guess I am kind of crazy, y'all. From y'all's point of view, I mean, I'm obviously eccentric, but look at these. I got little ghetto rigged up. Okay? It's the kind of guy I am. I don't care about what it looks like. I jot notes, and I got a lot going on with this little concept here of all concepts. And don't be confused by this. These are simple equations that just explain a lot. A whole lot, actually. But basically, though, yeah. At this point, if you still think I'm crazy, literally, if you're still listening at this point and you think I'm crazy, I'm not calling you any of you absent-minded, except if you think I'm crazy at this point, either go watch again or realize that you are being absent-minded in your present state. It's pretty ignorant, but other than that, like, please leave questions, anything, any holes you see, and obviously there's a lot of places where it seemed like maybe I just wasn't sure, and maybe in certain areas I'm not nearly as sure as in other areas, but a lot of it is just, it's going to take a lot longer to, I need like an hour or two to really, at least, I could use like 10 days, but it's basically everything leading up to this, everything. It all comes down to positive, negative, I'm trying to think of. There's so much. It's everything is a representation of the extension of its prior, what it came from. I'm just not even gonna. I'll get into all that, and I'll have to break it down to where you start from somewhere, and I'll have to find a really good place to start and just break it down. I've basically started it, but there's so many ideas. I've got to find a way to tie them all together. And but anyways, leave as many questions as you got to know. Like I said, I know it seems crazy, and don't give a fuck. Any questions or anything like that? Holla at your boy, man. Get at me, like for real. Like we can. I don't know, man. We'll figure it out. But yeah, good shit. Good shit.